Welcome back to the video lecture of module number 5, Instrumental Methods of Analysis. In the previous video lecture, we come to know the discussion on Beer's law, Lambert's law and Beer-Lamberts law, and we come to know that how the Beer-Lamberts law is used for the measurement of amount of substance present in the color sample solution. Now let us move to the instrumentation part of colorimeter. So colorimeter instrument, it has the 5 important components. The first one is source of light, then filter, second one, then third one is sample holder or sample cell, then fourth one is photo cell or photo detector, then fifth one is display system, or it is also known as galvanometer. So let us brief out about these individual components and their importance. As you know that the colorimeter is based on the instrument. So source of light is very much essential for to pass into the color solution. So therefore the light bulb, what it is used in the instrument is what? Used by the tungsten filament, and this light source is passed through the slit or aperture, making it more intense. Then that light intensity is passed through the collimating lens or condenser lenses to make it to convert into more intense light radiation. Then that light is passed through the filter. Filters are made up of usually the colored glasses of different wavelength or different frequencies of light radiations are going to be passes through that. Then that light source is allowed to pass through the sample holder or sample cell where the sample solution is taken, and then that light is passed afterwards from sample solution or sample holder is fed on the photovoltaic cell or photo detector, where the light intensity is converted in the form of electrical signal. So those electrical signals are digitalized on the display system or over the instrument or over the galvanometer for the readout system. So this is what a simple representation of the colorimeter, the source of light. As I told you, the source bulb we are using, which is usually lightning by the tungsten filament. Then you have the second important component is filter. It allows the particular wavelength of light radiation by absorbing other wavelength of light radiation. Then cuvette or sample holder. Within this, the sample solution is taken in the form of colored. Then that light passes through from the sample cell over the photo cell or photo detector, where photo detector or photo cell, it converts the light radiation into the form of electrical signals. Those electrical signals are what fed into the recorder, where it is that recorder may be digital or may be analog, or maybe it is in the form of plotter, which will give the information about the light absorbed by the colored sample. Now let us discuss about in brief of these important 5 components, what they are present in the colorimeter. The first one is the light source. The most common source of light used in the colorimeter is a tungsten filament. Then second one is the filter. To select the particular wavelength are used to split the light from light source. Usually the colored glasses are used as the filter. Then fourth one, sample holder, that is test tube or it may be the cuvettes are used to hold the color solution. They are made up of usually glass and they are going to absorb the visible light radiation. Then fourth component is photo detector or detector or system. When the light falls from the sample holder, it is analyzed by the photodetector converting in the form of electrical current. Then measuring device. The current from the detector is fed into the measuring device, usually the galvanometer, that shows the meter reading that is directly proportional to the intensity of the light absorbed by the medium. Now let us discuss about the important part of this method is colorimetric estimation of copper. It is very much important from the point of your exam. So let us begin with the principle. Cupric ions, when they react with the ammonia to give the deep blue color of cupra-ammonium complex, according to Beer-Lamberts law, optical density of light absorbing medium is directly proportional to the concentration and thickness of the color solution. It means as the absorbance increases, concentration also increases, or vice versa. The plot of absorbance against concentration, you are able to get the straight line passes through the origin. So this is the verification of Beer-Lamberts law. Now in the chemical reaction, what I explained, cupric ions means copper sulfate. When it is made to react with the ammonia, it is a colorless liquid of 1:1. So it leads to form the deep blue color complex is called the cupra-ammonium complex. The structure is given here, where copper is the central metal ion surrounded by 4 amine ligands, is a coordination sphere with the 2+ charge, and sulfate ion is the present outside the coordination sphere to neutralize the charge of the coordination sphere. Now let us discuss about the brief theory about the experiment. So colorimetry is based on the Beer-Lamberts law. The extent of absorption depends upon the concentration of the solution and path length of the light passes through the solution, that is the size of the absorbing medium. Hence, absorption is directly proportional to C into T, or the same equation what I can write, A is equal to epsilon into C into T, where A is the absorbance, C is the concentration of the solution, T is the path length of absorbing medium, and epsilon is the molar absorption coefficient or molar extension coefficient, which depends upon the nature of the color solution. It is a constant. So Beer-Lamberts law is nothing but the combination of the Beer's law and the Lamberts law. Let us discuss about now the experimental procedure, how to perform the colorimetric estimation of copper in an engineering chemistry lab. Now you have to take 5 number 50 ml capacity volumetric flask, and they are labeled with the flask number 1, 2, 3, 4 and 5, and also one unknown sample is provided. In first flask label number volumetric, you need to transfer 5 ml of copper sulfate solution. Second flask 10 ml copper sulfate solution, third flask 15 ml copper sulfate solution, and fourth flask 20 ml copper sulfate solution, and fifth flask 25 ml for copper sulfate solution from stock is transferred with the help of burette. Done. In second step, for all the 5 flasks, you need to add 10 cm cube of 1:1 ammonia solution. Then, third step, dilute the solution with distilled water up to the mark, mix well. This is for the preparation of standard 5 solutions. Similarly, you have to prepare the blank solution by diluting 10 cm cube of ammonia without adding copper sulfate solution in one more 50 ml volumetric flask and making it up to 0 with the help of distilled water. This blank solution is taken to adjust the instrument for a 0 optical density or 0 absorbance. The next one, the test solution is provided by the lab or by the teacher, that is transferred into 50 ml cm cube and add 10 cm cube of ammonia solution as you followed in the previous standard solutions and dilute up to the mark with the help of distilled water and mix well. Then last step, measure the absorbance of all the solution. Before that, calibration is done for using the blank solution by selecting the filter 620 nanometer on photoelectric colorimeter. Then afterwards, all the 5 flask solutions and unknown solutions absorbance are read out and they are entered into the tabular column. So tabular column for the colorimetric estimation, it is as follows. As you know that you have taken 5 flasks are labeled with flask number 1, 2, 3, 4 and 5, and this is the unknown sample is given by the lab or from the teacher. Then as you know that volume of copper sulfate taken in the first flask is 5 ml, second flask is 10, third flask is 15, fourth flask is 20 and fifth flask is 25 cm cube, and unknown solution is not known to you because which is given by the teacher or from the lab. Then for all the 5 flasks including unknown solution, you need to add 10 cm cube of 1:1 ammonia. Then make total volume after that adding ammonia, dilute with distilled water, make the volume up to the 50 cm cube. Then you calculate the concentration of copper ions by taking the stock solution is 0.01 molar. Then after the dilution for 50 ml, the concentration becomes like 0.001 for the first flask, 0.002 for second flask, 0.003 for third flask, 0.004 for fourth flask and 0.005 for the fifth flask, and unknown concentration you need to calculate. So with the help of colorimetry instrument, you need to measure the optical density and read the absorbance from the colorimeter after calibration with the blank solution with 0 adjustment by using the 620 nanometer. It is observed that optical density values are going to increase consistently as the concentration increases. Hence, you have to plot the graph by taking absorbance along y scale and concentration is taken along the x scale. As a result, you'll be getting the 5 points in the increasing trend. All the 5 points, they falls in the straight line, passes through the origin. For unknown solution, you'll be come to knowing unknown OD. That unknown OD is pointed on the Y scale. Then draw the straight line. It intersect any point, passes through the origin. From that, if you draw the perpendicular line where it intersect on the X scale, that is the unknown concentration of copper ions. Hence, calculation it follows like this. From graph, concentration of copper ions will be taken as N for the unknown solution. Therefore, second calculation is what? Amount of copper ions in gram per dm cube is equal to N into equivalent weight of copper, that is 63.50. Therefore, after multiplication N value with the 63.50, you are getting the amount of copper in 1 dm cube of solution. So this is how you need to perform the colorimetric estimation of copper. Thank you one and all.